Planet Earth has experienced multiple ice ages throughout history, being entirely encased in ice at least twice. From pole to pole, the Earth has been a giant snowball on several occasions. Now the landscape has transformed, the ice is rapidly melting, and scientists are exploring what secrets could be hidden beneath this frozen tundra. It is home to the second largest ice sheet on Earth. This ice sheet is impressively thick, almost 2 miles deep, and covers 80% of Greenland. Rapid glaciers, such as Jakobshavn, move at an incredible 150 feet per day, reshaping the landscape, while coastal waters form icebergs that reach 300 feet high, around the height of the Statue of Liberty. But these features are not the island's only unique aspects. The frozen surface continues to conceal numerous secrets, some of which scientists have begun to uncover, revealing findings that were truly unexpected. Greenland, which spans over 836,000 square miles, more than 3 times the size of Texas, has a population of only 56,000 people, making it the least densely populated place in the world. Extremely cold temperatures render most of the island uninhabitable. However, the southwest coast benefits from the warming influence of the Gulf Stream, resulting in milder temperatures and a habitable environment where about 1/3 of the population lives. In central Greenland, temperatures perpetually stay below freezing. Snow in this region never melts, continually building up. Fresh snowfall on the Greenland ice sheet is initially light and fluffy, with a density of approximately 50 to 70 kilograms per cubic meter. As new layers accumulate, their weight compresses the underlying layers, increasing their density. At depths exceeding 260 feet, air bubbles in the snow can no longer be compressed, and the snow transforms into solid glacier ice. In total, Greenland contains 695,000 cubic miles of ice, believed to have been present for hundreds of thousands to millions of years. However, Greenland was not always frozen. Underneath its icy exterior is a massive rocky island that was once a thriving place, full of life with valleys, rivers, and numerous lakes. Even today, parts of Greenland remain ice-free. Further south in Greenland lies the Kingua Valley, the only forested area on the island. With ongoing temperature increases, this green area could potentially trigger the spread of vegetation to other parts of the island, gradually turning it green once more. In 1966, scientists from the United States military drilled nearly a mile into the ice in northwestern Greenland and discovered evidence of a past green environment. They found twigs, leaves, and remarkably well-preserved fossil plants, described by scientists as freeze-dried. When rehydrated, they appear almost as if they had been frozen just recently. Approximately 400,000 years ago, parts of Greenland were covered in spruce forests and tundra, flat, cold, and windy regions lacking trees but supporting hardy, low-growing plants. Today, these findings act as a time capsule, offering a glimpse into Greenland's ancient ecosystems. Greenland's thick ice sheet serves as insulation, protecting the ground beneath from the frigid temperatures and winds above. Simultaneously, Earth's internal heat warms the ground from below. In some regions, the ice sheet firmly adheres to frozen ground, providing stability. However, closer to the edges, where the ice sheet is thinner, the base has thawed and the ice rests on moist soil. If sufficient water is present beneath, it can accelerate ice flow, potentially speeding up the melting process. Currently, the Greenland ice sheet melts at a rate exceeding 200 billion tons annually, an amount sufficient to fill almost 91 million Olympic-sized swimming pools. Complete melting of the ice sheet would cause global sea levels to rise by approximately 23 feet, causing devastating damage to millions of people living along coastlines worldwide. A 2019 study indicated that around 680 million people inhabit low-lying coastal regions, and this number could surpass 1 billion by 2050. Currently, Greenland is losing ice faster than it accumulates, although complete melting is likely a long-term process. The immense scale of the ice sheet is difficult to comprehend. Its weight has exerted so much pressure that it has created a depression in the central part of the island, sinking at 1,000 feet below sea level. A similar event occurred approximately 20,000 years ago, when immense weight pushed parts of the Earth's surface deeper into the crust. Ice sheets once covered large areas globally, including Scandinavia, the Arctic, and significant portions of the United States and Canada. Interestingly, these areas are currently undergoing changes. Imagine Earth's surface as a giant shape memory mattress. Pressing down on it compresses it, but upon releasing the pressure, it gradually returns to its original shape. Similarly, as ice sheets shrink, the land beneath them rises, while neighboring areas compensate by sinking. This process is very slow, with some regions still rebounding while others, like the United States East Coast, will continue to sink for millennia. Compared to other regions, these areas face a heightened risk of rising sea levels. Today, Greenland is far from green. However, scientists have gained a look underneath its ice, revealing centuries of hidden features. In 2013, a canyon over 460 miles long, 6 miles wide, and approximately 2,600 feet deep was discovered. This canyon is more than 1.5 times longer than the Grand Canyon in Arizona, making it the longest known canyon on Earth. Though not yet visible, it lies buried beneath billions of tons of ice. This subglacial canyon was likely once a major river channel, formed by frequent floods that eroded the bedrock around 2 million years ago, and it may still channel meltwater deep beneath the ice sheet into the sea. Greenland also once held a massive lake, covering an area as large as Rhode Island and Delaware combined, approximately 2,700 square miles. This lake received water from at least 18 streams and reached depths of 800 feet. Today, the ancient lake basin is a sediment-filled depression, holding clues to a time when water, not ice, shaped Greenland's terrain. Decades of ice-penetrating radar surveys have revealed a network of mountain ranges extending thousands of meters above sea level. Their sharp peaks and deep valleys influence the movement of the overlying ice sheet, which conforms to the shape of the hidden mountains. Additionally, there are submerged fjords, channels carved by glacial forces, ranging from hundreds to over 1,000 meters in depth. Greenland's glaciers are in constant motion, and their paths are influenced by these subglacial mountains, which act as obstacles. They guide the flow of melting ice, altering its speed and direction, and fjords serve as routes for icebergs to reach the ocean. The island's icy cover not only conceals a mysterious past, but also a wealth of natural resources. Geological surveys suggest the presence of rare earth elements and precious metals. Elements such as neodymium, dysprosium, and europium, found in Greenland's bedrock, are vital for producing modern electronics, renewable energy technologies, and various high-tech applications. The island's subglacial terrain may also contain precious metals like gold, silver, and platinum. Furthermore, there is an abundance of water. Locked within the vast Antarctic and Greenland ice sheets, it represents over 68% of Earth's freshwater. Greenland's unique geological characteristics offer significant potential for geothermal energy development, a sustainable alternative to traditional energy sources. The concept involves harnessing heat from Earth's interior that rises to the surface, a process known as heat flow. The heat flow along Greenland's west coast is 3 times higher than the island's average. Unlike fossil fuels, geothermal power generation produces minimal greenhouse gas emissions. It is possible that Greenland could play a vital role in a carbon-free future. All these factors make Greenland a repository of valuable resources, and also a place where nature's ingenuity is clearly displayed. In 2010, scientists discovered unusual formations beneath the Greenland ice sheet. Initially, they thought these might be ghost mountains, similar to those found in Antarctica, but they were later found to be something different. Known as jelly roll sculptures, these icy formations, as large as Manhattan skyscrapers, reaching 3,000 feet high and 3,300 feet thick, number in the dozens within Greenland. The space between the island's ice cover and bedrock must be vast to accommodate structures of this size. These immense features are composed of an unusual type of ice, not layered but twisted or rolled, and can be up to 120,000 years old. Radar imaging has revealed that jelly roll sculptures are located just 6/10 of a mile below Greenland's surface. While the island was once thought of as a layered structure of snow, deeper layers reveal a complex, non-flat formation. The ice in these deeper sections appears bent and folded. The formation process, in simplified terms, involves ice growing from the bottom up during cycles of melting and refreezing of the ice sheet. Similar to building a sandcastle, wet sand solidifies at the base, adding structure to lower layers. Refrozen ice similarly adds to these layers, creating a complex, folded structure beneath the seemingly uniform surface, formed over hundreds or thousands of years. Deeper still beneath the massive ice sheet lies something far older. When Greenland was a temperate rainforest, an asteroid about 9/10 of a mile across struck the island. The impact was likely millions of times more powerful than an atomic bomb, causing magnitude 9 earthquakes and massive wildfires. Fortunately, this event occurred after the extinction of the dinosaurs and long before the appearance of humans. The asteroid left behind the Hiawatha crater, a 19-mile-wide impact zone now buried under 3,000 feet of ice. Discovered in 2018, the crater's location is significant. Situated under the northwestern edge of the ice sheet, sediment from below showed evidence of rapid and extreme heating. By analyzing sand grains, researchers determined the impact occurred approximately 58 million years ago. Greenland is one of Earth's most remarkable landscapes, holding secrets of our planet's past. Exploration of this barren terrain has only just begun, and future studies are sure to reveal even more. The secrets concealed beneath the vast ice expanse remain largely unknown. What could this almost otherworldly landscape be hiding? Clues to our planet's future, undiscovered animal species, or perhaps even evidence of a civilization lost to time?